Let's start learning from the first unit of graph theory. Okay, so here you can see the first page of unit 1. Okay, so here in this unit, let me give you an introduction about this unit. Okay, in this unit you are not having so many theorems. You are having uh, 2 or 3 theorems only. Other than everything is definitions. So in the examination they may ask you define define a symbol graph, or define a bipartite graph, or define tree. Okay, these kind of questions they may ask, definitions they will ask. So be prepared to face that questions in the semester examinations. Is that clear? Okay, so here in the first unit, in a previous year question paper, I saw this question. Okay, they asked like this: define bipartite graph and write the characteristics of bipartite graph. Okay, if they ask you question like that, what you will do? You will write the definition of bipartite graph first, right? So here you can see the definition of bipartite graph. Don't memorize each and every lines. Okay, understand it and write it by your own. So here bipartite graph means what? In general you tell bipartite means graph, the graph will have 2 partitions. That is, you are partitioning the vertex set. Okay, bipartite graph means you are dividing the vertices in 2 sets, you can say. Okay, you are dividing vertex set, or you are partitioned the vertex set into 2 subsets, that is x and y. Okay, in the above you can see x, in the below you will see y vertices. So in bipartite graph, you will have edges, no? One end of the edge will be in the set x and another end of the edge will be in the set y. So that kind of graph is called a bipartite graph. Is that clear? So if they ask you the characteristics of bipartite graph, just write the definition and then draw this figure, and what you can write. That is enough for now. Okay, so let me turn to the next page. Okay, so here you can see a named theorem, fundamental theorem of graph theory, or they may ask you directly by giving you the statement. Okay, so here, or they may ask you Euler's theorem, whatever it may be. The proof is same. Proof is this. The statements they may ask you in a different manner, but you have to know what they are asking. Okay, so you have to be clear in that. Okay, theorem this 1.1, you can see the statement, very simple statement, right? What is mean by this? In a graph you will have so many vertices, and for that vertices you can see the degrees of that vertices, right? So what you will do is you are adding the degree of each vertices, then you will get a value, right? That value will be equal to 2 into edges. Okay, what you will do is you count the edges in the graph G, and you multiply the number of edges into 2. So you will get an answer, and here also you will get an answer, and that 2 answer will be equal. That is what the fundamental theorem of graph theory. So here let's start writing the proof. In the proof, what you are doing is, first you have to consider a graph G. Okay, what is the name of the graph? G. And here after that you have to consider an incidence matrix, and you are denoting incidence matrix like this, M of G. Is that clear? Now in M, that is by the definition of incidence matrix, you are going to write two sentences. It is in M, in incidence matrix, the sum of entries in the rows corresponding to the vertex V is degree G of V. You can skip this line also. Okay, it is not important to write these two sentences. Okay, according to me, I will say it like that. It is not that necessary. If you can understand what they are meaning from that sentence, then you can write it on your examination paper. Otherwise, don't try to mug up it without understanding what it is. Okay, just skip it. So here, okay, in the next line what we are doing is write the left hand side of the statement, and then that is equal to sum of entries in M. M means what? This incidence matrix. Okay, write the left hand side, that is equal to sum of entries in M. You write like this, we know that, and then write this sentence. Mark it as equation number 1. Also we know that every column sum of M is 2. Okay, these are the things you are writing from the definition of incidence matrix. Okay, so here also we know that every column sum of M is what? 2. Therefore, sum of all entries in M is equal to 2 into epsilon. So from mark it as equation number 2. Okay, so here you will mark it as equation number 2. From 1 and 2 you will get what they are asking us to prove. Okay, here is nothing is difficult. What you are taking, first you will take a graph, and then what you will take, incidence matrix, and using that incidence, ignore the background noise. Okay, so here after considering the incidence matrix, what you are writing? You are writing something, right? The left hand side of the statement, and then write is equal to sum of entries in M. Sum of entries in M, and then what you have to do is, we know that sum of entries in M, the same line, the same thing you are writing, is equal to 2 epsilon. Now comparing these two, you will get what they are asking us to prove in the statement. Is that clear? Okay, now let us pass on to corollary 1.1.